Prove that n factorial is greater than 2 to the power of 2n for all integers n greater or equal to 9. We're going to use proof by induction here. So first up, let's try n equal to 9. On the left-hand side is going to be 9 factorial, which you can put in your calculator, ends up being 362,880. And the right-hand side is then 2 to the power of 18, which ends up being 262,144. So that means 9 factorial is greater than 2 to the 18, and therefore true, statement true for n equals 9. Okay, that's always stage 1. Now we're going to assume true for n equals k, some k that's greater than 9. Therefore, this is true, k factorial is going to be greater than 2 to the 2k. And we want to show that true for n equals k plus 1. That this one here implies this one. Okay, because then we're showing that, for example, 9 implies 10, which implies 11, which implies 12, and so on. They're going to be true from then on. And I think it's good to just write in brackets what we're trying to get to. We're trying to show that k plus 1 factorial is greater than 2 to the 2. Oh, sorry, run out of space. 2 to the 2k plus 1. All right, well, let's start with k plus 1 factorial. And we're going to somehow use this to help us out. Now this is going to equal k plus 1 times k factorial, because that's what k plus 1 factorial is. It's k plus 1 times k minus 1, but you can just kind of separate it into these two things. And now we're going to use that statement. Well, I know that this is going to be greater than k plus 1 times 2 to the 2k. I've just replaced this by this and then use. Okay, I'm on my way. Now remember, k is greater than 9. So I know that this is going to be greater than 10. I mean, I could have said that it's greater or equal to 9, but I don't need to do that actually, because I've already shown it's true for n equals 9. So it's okay to do this. If you end up putting a 9 here instead, it's absolutely fine. But this is going to be greater than 10 times 2 to the 2k. I'm just going to write in brackets since k is greater than 9. Now, I just want to look at where I'm heading. I'm trying to get to here, which is actually 2 to the 2k plus 2. It's sometimes good to look at what you're trying to end up with and just kind of play around with that, because that would be 4 times 2 to the 2k. I'm kind of now going to do that backwards. So this is definitely going to be bigger than 4 times 2 to the 2k. That must be true. But that there is then equal to 2 squared times 2 to the 2k, which is equal to 2 to the 2k plus 2, which is equal to 2 to the 2k plus 1. And when I put it together, I have shown that k plus 1 is greater than, it doesn't matter that I got equals later on, greater than this here. So n equals 9 is true, and n equals k implies, n equals k true implies n equals k plus 1 true. So in fact, yeah, 9 implies 10, which implies 11, and so on. I always like to say then, by the principle for mathematical induction. N factorial is greater than 2 to the 2n for n greater or equal to 9.